Okay, so for today's video lesson, we're going to be calculating the surface areas of right pyramids. Okay, so a right pyramid is a three-dimensional object that has triangular faces and a base that is a polygon. So a polygon is just a shape, so a square, circle, or yeah, square, triangle, pentagon, hexagon. And the shape of the base determines the name of the pyramid. The triangular faces will meet at a point called the apex. Okay, and before I go any further, I'm just going to go ahead and just draw a general right pyramid here. And you'll have to excuse my drawings because I did not go to university for art school. Okay. So here is the apex that I was talking about earlier, right at the top. This is the apex. Okay, so from there, we will introduce the height of the pyramid. Okay, so the height of the pyramid goes from the center of the base. It forms a perpendicular line, so a right angle, to the apex from the center of the base. Okay, so that is my height. Okay, and just to put that into the words, so the height of the pyramid is the perpendicular. So it forms a right angle, is the perpendicular distance from the center of the base to the apex. All right, so that is the height. From there, we have the slant height. So that is going to be the height of the side of the triangular face, okay? And that is the slant height. Okay, note that this is different than just the height of the pyramid, okay? So the slight height of the pyramid is the height of the triangular face. Okay, so just some terminology for us there. So make sure we are familiar with these terms before going forward. Okay, so surface area, this term should be familiar to you. This is going to be the sum of all the areas of the triangular faces and the base, okay? So surface area is just kind of the area on the outside of the surface, or of the shape, okay? So just a note here. So when the base of a right pyramid is a regular polygon, so this is where all sides of the polygon are congruent. What we mean by congruent is the same. So if it's a pentagon, all 5 sides are going to be the same length, or if it's a square, it will be a regular polygon. If it's a rectangle, it is not a regular polygon because all sides are not the same length, okay? But if it is a regular polygon, so if it's like a square at the base of our pyramid, then we know that the triangular faces are congruent. And again, congruent is the same. Okay, so a tetrahedron, this is a 3D shape. This is a triangular pyramid. Okay, so the base is also a triangle. So think of a 4-sided die here, okay? And this regular tetrahedron, okay, where all of the triangular faces are going to be the same side length because all sides of this triangle will be the same. Okay, so a regular tetrahedron has four congruent equilateral triangular faces. Okay, all I'm saying here is that all four sides are the same. All right. So we're going to use some formulas here. These should be pretty familiar to you guys. You would have seen them at one point or another. Maybe the Pythagorean theorem might be new to us, but that's okay. We'll go over that. Okay, so we'll start with the area of a triangle. So here's just that's a terrible triangle. There we go. That's better. So just a regular triangle there. We have a base, and we also have a perpendicular height there. Okay, so we have to be sure that we use the perpendicular height from the center of the base to the vertex. This is the vertex up here. Okay, and we have to be sure that we don't just use the side length here. Okay, the side length does not equal the height. Okay, but the formula to find the area of a triangle, so area is equal to the base times the height divided by 2. Okay, you might have seen this before, like this. Area is equal to 1/2 times the base times the height. Okay, both of those formulas are the same, although they look differently. Whichever one you prefer to use is up to you. Okay, but to calculate the surface area of a triangle, it is the base times the height divided by 2. Okay, and again, that's the perpendicular height. For a rectangle, okay, it's a little bit better than my triangle. We have a length and a width here. This should be easy for you guys. Area is equal to length times the width. That's for a rectangle. Okay, and if it's for a square where all four sides are the same, okay, which can be indicated by these markings here. Okay, that just means all of the sides are equal length. Okay, to find the area of a square, you could multiply the side length by the side length, similar to what we did for a rectangle. Okay, or if we wanted to simplify this, we could say surface area is equal to the side length squared, because they're the same term in a square. Okay, down to the Pythagorean theorem. So this works only for right angled triangles. So that's indicated right there. Okay, so the legs are A and B, and the hypotenuse is C. The side across from the right angle is the hypotenuse. And the relationship between these side lengths here, A squared plus B squared is equal to C squared. Okay, these three formulas are pretty important. You will use them throughout the remainder of your high school mathematics. So you will know these if you don't know them already. All right, we're definitely going to be using these today. So let's get going. Okay, so Jean-Marie measured then recorded the lengths of the edges and slant height of this regular tetrahedron. So again, regular tetrahedron, all four sides are the same in terms of surface area and side lengths. Okay. So that's gonna make it a little bit easier for us. What is the surface area to the nearest square centimeter? Okay, so we have four triangles here. So to find the surface area of a triangle, it is base times height divided by 2. Okay, so this is my base is 9. and 7.8 is going to be the height. Note that is the perpendicular height from the center of the base to the vertex of the triangle, okay? Not the side length. Okay, so it's just base times height divided by 2. So I'll just substitute those in. So area is equal to base is 9. Units are centimeters on here. Okay, so it'd be 9 centimeters multiplied by 7.8 centimeters divided by 2. Once I punch that into my calculator, I get a surface area equal to 35.1 square centimeters. Okay, now that is only for one of the triangle sides here. However, we have 4, so we need to multiply that by 4 sides. Punch that into your calculator, we get a value of 140 and 4/10 centimeters squared. Now the question is asking us to answer to the nearest square centimeter. Okay, so we have 140.4. It is 4 or less, so we're going to let it rest. Okay, so my final answer, surface area is equal to 140 square centimeters. Okay, easy peasy. Make sure we are including our units with our answer, because remember, a number with no units is simply just a number. All right, moving on. So a right rectangular pyramid has base dimensions 8 feet by 10 feet and a height of 16 feet. Calculate the surface area of the pyramid to the nearest square foot. Okay, so this is a right rectangular pyramid. So first thing we have to note is that our side lengths are different, which means that when we calculate the surface area of the triangular faces, we're going to have to calculate the sides and the front and the back separately, okay? So it's important that we just take that into consideration. So I'm going to go ahead and attempt to draw a right rectangular pyramid. This one's not bad. Okay, so my base dimensions are 8 by 10 feet, and the height, so remember the height is from the center of the base to the apex, and that forms a right angle. And my height is 16 feet. Okay, so we know the height when we know the base dimensions, but we do not know the slant height. Okay, and also we need to note that our slant height on the front and the back are going to be different than the sides. Okay, so slant height for the front and the back is going to be different than the sides. So let's go ahead and do our sides first. So 1, find slant height for sides. Okay, and throughout this video and through any video lesson, I would encourage you, if you feel ready to solve the problem on your own, I would definitely encourage you to pause the video and attempt it on your own. And then if you get stuck, feel free to use this video as a reference to kind of help you, okay? But yeah, that goes without saying for any of the video lessons here, okay? So anyways, I'm finding the slant height for the sides, okay? So we need to look at the triangle that is going to be formed here, okay? So halfway from the height, like where my where the height comes out of the base to the apex, okay, that is the center point, right? So from the base there, I know that is going to be 5 feet, okay, and I also know that the total height is 16 feet, okay? That kind of draws a right angle, okay? So now my slant height is going to be my hypotenuse. Okay, so I'm going to use S for that one here. Okay, great. So hopefully you guys can see that right angle triangle that is inside of that right rectangular pyramid. Okay. Yeah, so I know it's 5 feet at the base, 16 feet going up, and then I'm looking for my slant height. Because it's a right angle triangle, we can use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now, which side you label A or B does not really matter as long as you have C as your hypotenuse, okay? So generally it's a squared plus b squared is equal to c squared. In this example, I'm looking for the side length or the slant height. So I'm going to use s squared just to be consistent with my variables, okay? So A is going to be 16, okay? Sorry, but before I go there, I want to just isolate S, my side length, okay? So I'm just going to take the square root of each side. Okay, square root and square canceled. Now I have slant height is equal to the square root of a squared plus b squared. Awesome. I like to manipulate things algebraically before I do my substitution. I think it's a lot cleaner in the numbers, and if you're good algebraically, you'll be really well off when you get into grade 11 and 12. Okay, anyways, let's get into the substitution. So slant height is equal to the square root. I'm going to say A is 16 squared plus 5 squared, which is my other term, okay? So 16 squared plus 5 squared is equal to 281. Now I'm going to keep it as a radical here because this is an exact value, okay? If you want to just get rid of the square root sign, I don't blame you, but its approximation is approximately 16.76, okay? So now I know that this side is root 281, or if you don't like that, we can say the slant height is 16.76 feet. Okay, so what am I doing? Now that I've found my slant height for the sides, I can calculate the surface area of both the sides, okay? So find, I'll use a different color for that. 2. Find surface area for sides. Okay. So surface area for a triangle, area is equal to base times height divided by 2. I know my base width is 8 feet here. 8 feet multiplied by my height, which is 16.76 divided by 2. And that gives me a surface area of 167.63 square feet. Should include my units here. And that is for one triangle, okay? So that's for this triangle right here. But we have 2 side lengths, so I'm going to multiply it by 2 and get a value of 335.26 square feet. Okay. For sides. Now I'm just going to hang on to that number so I don't lose it, okay? I'm going to jump over here because I only have a limited amount of space. Okay, now step 3, I'm going to find my slant height for the front and back. Okay, so similarly, we're gonna try to find a right angle triangle in the front here for the front and the back, okay? So coming towards us, I know it's hard to visualize this, but coming towards us right here, it's 4 feet, right? Because it's half of the 8-foot base, okay? And then going vertically, going up and down, okay? Sorry, I'm out there, okay? So right here, we have 4 feet. Going vertically, we have 16 feet. So 4 foot there, going up, we have 16 feet. And then going down is going to be the slant height for the front and the back. I'm going to use C here. Okay, so Pythagorean theorem, Pythagorean theorem, a squared plus b squared is equal to c squared. I just want to find c, so c is equal to the square root of a squared plus b squared. A is 16, b is 4 squared. Okay, so punch that into your calculator, you get a front slant height equal to 16.49 feet. Okay, so this is 16.49. Now that I know the slant height, let's find surface area. Let me use a different color. Green. Find surface area of front and back. A lot of steps here, especially when we don't have a regular polygon as the base, right? Okay, so surface area of the front and back. So area is equal to base times height divided by 2. So my base is 10 feet times the slant height, which is 16.49 feet divided by 2. Gives me a surface area equal to 82.46 square feet, excuse me. And I have 2 faces, right? The front here and then the back. The surface area of the front and the back is equal to 164.92 square feet. Front and back. Okay, so we've done the front and the back and the 2 sides. So now we need to find the base area. It is a rectangle, so area is equal to length times width. Length is 10 feet times 8 feet wide. And that gives us a surface area of 80 square feet for the base. Okay, so now that we have the base, the front and the back, and the sides, let's go ahead and add them up together for our final answer. Let's do black. Okay. So we have 335.26 square feet for the sides, plus 164.92 square feet for the front and the back, plus an 80 square foot base, for a grand total of 580.14 square feet. Now the answer is asking us to calculate it to the nearest square foot. 1 is less than 4, so let it rest. So surface area of the pyramid is equal to 580 square feet. All right, that was a lot of work. I must admit. Okay. So let's go ahead and find or derive a formula to calculate the surface area of any right pyramid which has a regular polygon base. So if it has like a square base or a regular pentagon where all sides are the same. Okay, so this is a square. This is indicating they're all the same lengths. And I'm gonna draw our apex here. Can't tell if they're getting better or worse. Okay, so here is a right, it's just a pyramid, right? A square pyramid. We have the height from the center of the base. Okay, and we also have a slant height, which is the height of the triangles. Okay, so slant height. Okay, so the triangular areas, we're going to call these the lateral area. Okay, the lateral area, and then the base area is the very bottom. Okay, so we can say for any polygon that the surface area is equal to the lateral area, okay, which is the triangular faces, plus the base area. Okay, now in our base area here, we have side lengths. Okay, they're all the same. Now, to calculate the lateral area, okay, we have four triangles multiplied by the length of the base multiplied by the slant height divided by 2. Okay, length times the slant height divided by 2, that is the formula for surface area of a triangle. Okay, so that's our lateral area, and because we have 4 of them, it is 4 multiplied by length times slant height divided by 2. Okay, and then still plus the base area. So again, this 4 here, we're multiplying 4 triangles by the formula for the surface area for one triangle. Okay, now I'm just going to rearrange this. So instead of 4 multiplied by length times side length, I'm going to have 4 length and slant height divided by 2. Okay, it's the same thing. I'm just rearranging this plus our base area still. Okay. So 4 length here, that is going to be the perimeter of the base. Okay, and we still have slant height divided by 2 plus the base area. Okay, so just to kind of wrap this up and put a nice little bow on it. So surface area is equal to, we're still going to have our slant height divided by 2. Okay, multiplied by whatever the perimeter of the base is. Okay, whatever the perimeter of the base is. So in this case, because all 4 side lengths are the same, you could multiply length by 4 to calculate the perimeter of the base. Okay, but if you have a pentagon or a hexagon as the base, you can just add up the perimeter and then multiply it by s over 2. Okay, so that's really nice. Okay, so instead of having to calculate the front and the the front and the back and the side surface area for like a right rectangular pyramid, we can just calculate the perimeter of the base and multiply it by slant height over 2. Okay, sorry, but note that this only works for regular polygon bases. So we can use this for a right rectangular pyramid. Okay, it needs to be all sides are the same. Okay, so plus the base area. Okay, so this formula here is true for any pyramid with a polygon base. Okay, so actually I lied when I said you could use it for that really long problem that we just went over. But I probably won't make you do a question as extensive as the one that we just did. Good news. All right, let's try out this formula and then we will wrap up this lesson, okay? So we're going to determine the surface area of a right pyramid, okay? So a right pyramid with a base that is a regular pentagon. So a pentagon has 5 sides. Okay, they said it's a regular pentagon, so all of the side lengths are the same as indicated by those sides, okay? So this pentagon has a side length of 2.4 meters, and the distance from each vertex to the center of the base is 2 meters, okay? And the height, so let's try to put a cap on this. I'm try to put it over here. Thanks. You have to use your imagination a little bit, okay? But the cap on this height is equal to 3.9 meters. Okay, so it's a regular pentagon, so we can use our formula that we just derived from last slide. So surface area is equal to slant height divided by 2, multiplied by the perimeter of the base, plus the surface area of the base. Okay, so we know the height, but we do not know the slant height, right? So we need to find the slant height, okay? We know that, maybe I'll draw it on this one, you can see it a little bit better, okay? So there's our slant height. To the middle, it is 2. And then we know that this height right here is 3.9, okay? So hopefully you can use your visualization brains there, okay? So I have 2 like that, 3.9 as a height, and then we're gonna find that slant height here, okay? I'm gonna label it first as C. Oh, maybe I'll use S. For slant height. Okay, so again, we have a right angle triangle here. So a squared plus b squared is equal to c squared, but I'm going to use s squared for my slant height. S isolated is equal to the square root of a squared plus b squared. Okay, a is 2, b is 3.9. Punch that into your calculator, you get a slant height equal to 4.38 meters. Okay, slant height. Awesome. Okay, so now that we know our slant height, we have this part checked off. We can find the perimeter quite easily. Okay, so we'll do that when we get there. But let's go ahead and find, we have found the slant height already. Perimeter is going to be easy to find. Let's go ahead and find the surface area of the pentagon, okay? Okay, so right now we know this is our triangle. We know the side length is 2 and we know the base is 2.4, okay? But we don't know the perpendicular height of this triangle. Okay, we need to find the perpendicular height. We cannot use the slant or the side length to find the surface area of the base here, or of just in triangles in general. Okay, you cannot use the side length. You need to find the perpendicular distance from the base to the vertex of the triangle. Okay, so I'm going to cut this triangle in half. Okay, so it's still 2. It's 1.2 to here. And I want to find this side length. I'm going to call it A. Okay, that is my perpendicular distance. Okay, this is still a right angle triangle. Okay, so remember this has to be C, and this is going to be B. Okay, C has to be hypotenuse, which is directly across from the right angle. So A squared plus B squared is equal to C squared. I want to find A, so I'm going to get A by itself. So minus B squared from both sides. Take the square root. Now I have A is equal to the square root of C squared minus B squared. Okay. So remember, C squared is the hypotenuse, so 2 squared minus 1.2 squared. And I should be clear with my notation. I honestly didn't put these brackets in for any reason. I should have been better with that. Let's fix it. Minus 1.2 squared. There we go. Okay. Punch that into your calculator. You will get a slant or perpendicular height here of 1.6. Okay. Please note that everything is in meters here. So it's going to be 1.6 meters will be A. Okay. Now that I know my perpendicular height here, okay. Sorry, I'm just going to. Anyways, right here. So this height here, for my vertical height there is 1.6. Now to find my surface area of triangle, it's base times height divided by 2. So my base is 2.4 meters times 1.6 meters divided by 2. Okay, so 2.4 times 1.6 divided by 2 is equal to 1.92 square meters. Okay, but that's only for one triangle up here. Okay, that's only for that one triangle there. There are 5 triangles in a pentagon, so I need to multiply that by 5. And this will tell me the surface area of the base. Is equal to 9.6 square meters. Okay, so now I have the surface area of the base. I have everything that I need to use this formula. Okay, so surface area is equal to my side length over my slant length over 2, which is 4.38 meters divided by 2. My perimeter, okay, so one side length is 2.4. So 2.4 meters times 5 sides. Okay, and then I'm going to add the surface area of the base, which is 9.6 square meters for a final calculation equal to 35.90 square meters. All right. All right. So your assignment for the remainder of today's class is to work on these textbook problems here. Yeah, so start chipping away at those. The second half of this lesson will be for tomorrow. So, and then there's going to be a quiz towards the end of this week. Okay, so if you have any questions or you need help with anything, please reach out. I'm more than happy to help. Thank you. Have a great day.